Okay, definition time. So a sequence AN, so that's this sequence here. That's this sequence here. So a sequence AN is bounded from above if there exists a number M such that AN would be less than or equal to that M for all N. So basically what it's saying is that this sequence here is bounded from above, if there exists an M, if there exists a number M where all the terms of that sequence is always less than or equal to M for all n meaning all the way as n goes towards infinity. So this sequence is bounded from above, if there exists a number M here where all the terms of that sequence is always less than less than or equal to that M, so for all n. So if you have a sequence like this going all the way to infinity, then there is no ceiling here. The sequence goes beyond that ceiling. Here you've got a ceiling where this sequence here will never go above that ceiling. It's always contained within that ceiling. So we said that this sequence here is bounded from above, and then the number M, that's this number here, the number M is an upper bound for that sequence. Okay, so if and then the next part is quite long-winded. You have to read it for yourself several times to really understand what's going on. So it's saying if M is an upper bound for the sequence, but no number less than M is an upper bound for that sequence, then M is the least upper bound for that sequence. It's a bit long-winded, but read it for yourself and try and understand it. What it's saying is that, let me just extend this graph. What it's saying is that this here is like one ceiling. It is capital M, but then you see the sequence here is always less than this ceiling here. But then there could be another ceiling where this sequence is always less than this ceiling here. But then there exists another ceiling where this sequence where this sequence is always less than that ceiling. But then there will come a ceiling where no other ceiling less than this ceiling is the upper bound for that sequence. Basically, it is long-winded, but what it's saying is that this ceiling here is your least upper bound for that sequence. Well, that's what this long-winded sentence is saying. Read it for yourself, but that's what it's saying, because there are lots. You see, this here is an upper bound. This here is an upper bound. This here is an upper bound. But then there will come an upper bound where there will be no other lower upper bound for that sequence, if that makes sense. So this here is your least upper bound for that sequence. I will continue in the next video, but basically, no, actually, I will carry on actually. So this bit here is pretty much the same as the above, but it's saying that it's bounded from below, meaning that there's like a floor to this sequence where the sequence will never go below that floor, basically. And then the sequence, if the sequence is bounded from above and below, but basically if the sequence is bounded from above and is bounded from below, basically it's trapped in a tunnel, if you like. If the sequence is trapped within a tunnel, then we say that the sequence is bounded, just bounded. Okay, and then if so that's what it's saying. If it's bounded from above and below, meaning it's trapped within a tunnel, then we say that this sequence is bounded. Okay.